Today to hear me talk about this topic, which I love to talk about, which a good friend of mine reminded me yesterday. He's like, hey, so all this talk about the Internet of Things, he's like, it kind of validates what you and I were talking about like 5 years ago. I'm like, oh, at least one person remembers. Not that I'm looking for validation. Again, I'm just really excited that everyone's showing interest and came out today, so thank you for that. So just a couple of things about me. I always try to have fun with the About Me slide, so I really broke this one down to really short and sweet, right? That's my work thing. This is my podcast thing. I enjoy things like that, and I hack things like that, right? Next slide. Okay, so some things about this presentation. Yeah, I'm going to say the Internet of Things. I'm not really super happy about that term. I don't think it really quite captures what we're talking about today in the fullest sense of the word. What this talk will not be about is you're not going to see me come up here and hack into a device and say, wow, that's really cool, look at how vulnerable it is. Are there any ways to defend this? Well, I don't really know. That's not the kind of talks that I like to give. Although it is really wicked fun, like we say in Rhode Island, to hack into things. So I do have some examples that I want to share with you because it's a really good example of how an embedded device is vulnerable, and it's a really, really funny story. It involves Russians, reverse engineering firmware. It's awesome. So also, the sky is not falling because we have this problem yet. However, I'm going to share with you predictions. Unfortunately for me, this will be captured on the internet, so I get to see if my prediction comes true or not. But I do have some predictions as to some of the bad things that could happen when we talk about the Internet of Things. So it's more about real attack vectors, and I've spent probably way too much time thinking about this topic, about what could we do with these embedded systems. I think it stems back from when I worked for a university and I would break into printers, and I'm like, well, what could someone do with that? I was really, really curious, and that curiosity never left me. So I've expanded it to the topic that we'll talk about today, and I'm gonna define for you what I determine and deem as an embedded system. And you can say whether you agree with that or not, but that's gonna help frame the discussion for today. Understanding some of the different types and applications and more. Also some of why these systems are vulnerable, which I think is really important, and I've spent some time thinking and talking to other really smart people about how we're in the situation we're in today. Hopefully that will give us some insight as to how we can make it better, which is really what I want to spend most of the time talking about today, hopefully. Although if I have some time, I do have a little demo about ripping apart some firmware, because it's fun. But I want to talk more about what we do about it. And this recommendation, right, these tips that I have are for manufacturers of embedded systems, but most importantly for all of you as well. I want all of you to be armed with the knowledge of what can we all do better, what can manufacturers do better, what can software developers do better to help make this problem go away. Okay, so I found this definition for embedded systems. I searched for a really, really long time to find a good definition, and this was my favorite. I do quote the research here as well. An embedded system is a special purpose system in which the computer is completely encapsulated by the device it controls. I think this definition nails it, and this is one of the criteria that I put forth in my presentations and in my training for the types of systems that we work with, right? Lots of examples of that. A universal remote happens to be the same one I have in my house, right? Another embedded system that a couple of you in the audience might recognize, right? That's a Pony Express Pwn Plug R3, and a Sonos system, right? They all fit this definition, right? They fit the definition. Consumer devices that fit within this definition. Cars are, there's like a whole other subject in and of itself. I would still say that cars fall within this definition. We won't talk too much about car hacking today. Washer, dryers, toilets. Yes, you're pointing at the toilet. I really want a Wi-Fi toilet. And the ones they have heated seats, and they spray you with water, and I really wanted to send a tweet so all of you can know exactly what's happening at all times. I think that would be really, really cool. So yeah, those are some of the devices I have in my home, and they all fit into my definition, the Nest thermostat being one of them. Now, what's interesting about the Nest thermostat, of all the research that I've seen that's been made public, nothing is talked about a remote attack for a Nest thermostat or attack the firmware. The things that I've seen are, plugging in all of this stuff and soldering things onto the Nest thermostat. Now, I think that's really cool, don't get me wrong. I greatly respect the research that people are doing with the Nest thermostat. However, there was a post on the Daily Dave list, and, my good friend Jericho, I think, said it very, very well. He said, these attacks are great, however, someone can also break into my house and smother me with my pillow, or, they could solder a bunch of stuff onto the Nest thermostat. So, when we talk about real-world attacks, we'll be more real-world than this, although I think that's really cool, though. So, oops, sorry. Okay. So you saw a preview of that. I usually don't put transitions like that in my presentation, but I wanted to ask everyone, when do you think people started caring about security on their home computer systems? Does anyone have a guess? Ransomware, right? Spyware, adware, porn. That, everyone always, when I ask this question, talks about the flurry of porn pop-ups, right? I mean, this is when people started caring, is when their desktops look like this, right? When they used to see this, or maybe they still see this to this day, what do? Oh my God, I need antivirus software. Oh my God, I have to call up the first friend or family member that I know that knows anything about computers, which is probably all of you in this room have been the person on the other line of the phone, and make this go away, because now I can't get to my porn, well, yeah. So that's when people started, to me, that was a driver for security, right? And I think a really big one. So this kind of translates to embedded systems. And what's interesting for me is the movie Idiocracy really influenced this slide, right? Because the guy's watching his favorite TV show, Ow My Balls. I mean, it's a cult classic, right? We're not going to dispute that. However, all around the screen, right, are all these ads that are permanently there. And that got me thinking, well, people are going to care about the security of their TV, not when I stand up on stage and go, look at me, I can hack into a TV and change the firmware and all this stuff. They're going to care when they're sitting there watching their favorite TV show, Ow My Balls, and is this for me to sip lovingly during the Thank you. I love it when you're gentle, Dave. Thank you, I think. Oh, that's warm and scrumptious. So the day that people are going to care is when they're watching Ow My Balls and advertisements start coming up on your screen, right? Because we all know attackers are completely ethical and would never put ads on your devices to make money. They would never take advantage of vulnerabilities and use exploits on those devices to pop up ads and make money. Because that's really not how the computer underground works today at all. Of course it is, right? So ads could be displayed without your permission, and not just on your TV, but other devices as well. And that, I believe, is going to be some of the driver. And we start to extrapolate that out. This is a proof of concept refrigerator that I found. Now, secretly, I really, really want one, right? I don't think they make these. I think this is just like someone's sketch, dream idea. But just to give you an even further glimpse into the future, so you can see everything in your refrigerator, right? It's clear. And then this whole thing is a touch surface. So you can inventory everything in your refrigerator. This particular one will go out online. It'll help you do recipes, and it will then read you the recipe and tell you how to cook your meal, with a speaker inside of your kitchen, and give you step-by-step instructions. I thought that was pretty cool. But the thing is, now I've got this gigantic surface where the thing about ads really comes in, right? I mean, we're going to talk about some privacy things that could be very interesting, but from a sheer perspective of caring about security and actually pushing manufacturers to say, hey, the consumer's going to care about security, and the consumer's going to make purchasing decisions maybe based on the security of these devices, or become really frustrated with your product because of this huge touchscreen surface where ads could exist. Because as we all know, which we'll establish a little later, is that most embedded systems like this are horribly insecure. Okay, so why else might I care? Well, so what? I can see you watching TV, right? Okay, that may not be a big deal. But maybe I know what you eat and drink, or how often you do laundry, and when you turn your lights on, how long you spend on the toilet. See, for me, you'll know that because you'll get a tweet, which is nice, convenient. Maybe I start to collect all of this data now. It's one thing to have this privacy violation, but another thing to collect all this data and use it to start sending more targeted ads. Now, the thing that was kind of interesting for me is some of these devices have cameras, right? That refrigerator I showed you, there are actually refrigerators on the market today that you can buy that have a camera inside of the refrigerator. And you get an app on your smartphone so that when you're at the shopping in the supermarket, you can look inside your refrigerator and go, oh yeah, we really are low on milk. And as Larry pointed out, ever so eloquently, now I can see if the light really does go off when I shut the door. That was like Larry's whole thing with the camera inside the refrigerator. He was very concerned. If I had that, that'd be awesome. But that also brings up privacy concerns. So someone was mentioning to me, I forget who it was, but they said, there was a certain kind of attack where if you could collect this data from the refrigerator about what was in there, you could identify diet needs and also tie that to health issues as well, which is also kind of another spin on that. But what I'm more concerned about is that when I get a snack from the refrigerator at 3 a.m., I'm usually in my underwear, okay? Larry, I know you don't wear pajamas. Don't ask how I know that. But Larry does not wear pajamas. And when you open the door, like, is the camera on the door? Is it shining at you? That there's a potential privacy violation right there. Okay, enough of that. But some of these other things are real as well, right? Like, look at the size of the screen on this washer dryer, right? I mean, it's as big as my smartphone. Again, that could be another vehicle for ad delivery. And we talk about ransomware, we talk about adware, spyware, all of that kinds of stuff existing on these systems. The interesting thing is, ads aside, I mean, even if you are getting an ad, right? We can see on our computers what's happening. On these devices, the user interface is almost often removed, right? I don't have a mouse and keyboard on my washer and dryer to go into, run a PowerShell script to do some forensics. I just don't have that on my washer dryer unless I've hacked it. So these devices, I think, are really easy for us to hide malware. While they might not be the most high-powered systems, they're going to be targets from attackers because of the ability to hide. Is one of the things that I like to point out when people say, well, why would you want to hack into someone's washer or dryer? Now, what if this could be prevented, right? Now, we can't stop human stupidity. However, what if this could be prevented with some patches, right? I mean, the treadmill is one of the interesting devices in my home that I have presented on before. I have found vulnerabilities in it. It does run Android. But one day it said, do you want an update? And I'm like, damn, I got to apply this update. I really don't want to, but I don't want my wife doing that because I didn't update my treadmill. Also, one of the things that I like to point out that I don't necessarily address in my top 10 list and probably needs to be adjusted is right here. I don't know if you can see that, but it says, hey, in this release, we had some bug fixes. What? Okay, but what does that mean? Did you fix vulnerabilities? Was there a spelling mistake? Because there's a big difference between a spelling mistake and a remote exploit. A lot of times embedded manufacturers will hide the fact that they're fixing vulnerabilities in these devices. I've seen that a lot with wireless routers as well. I suspect, since this doesn't come up as vulnerable Android on my network any longer, that they actually did update security patches and just called them bug fixes. Okay. Well, attackers will use these systems to monetize. Of course, we've seen a lot of examples in the news about using them to mine bitcoins and build botnets. Look, it doesn't matter what kind of system you own to build your botnet. As long as it can do what you need to do inside your botnet, you're good, right? And I think, again, it comes down to that stealth issue as to why people are choosing those. Also, there are some Netgear storage devices that have more computing horsepower than the systems I administered when I started at university. Being a systems administrator, and that was like 10 years ago or something. So embedded systems are getting much, much faster, more capable. So using them to build a botnet, while some in the press will say, well, this is ridiculous, I'm saying, no, this is a viable option. It can do things like mining bitcoins because I get maybe a larger or a big enough botnet to do the computations, but it stays there longer because people don't notice that their DVR or their security camera was owned. Okay. Some of the other classes of attacks, of course, industrial control systems. I won't spend a whole lot of time talking about this. We've seen lots of examples. The reason I like this slide is all of these systems up here have had a vulnerability that is discoverable by Nessus, which I think is interesting. A lot of them are backdoors and the like, and we'll talk about a specific example later on. Why do we care, though? I mean, let's dig into... I'm glad you can see that image. I told you they'd get better. So the reason that we would care, right, potentially life-threatening, of course, with SCADA applications or industrial control systems more accurately, they're historically operated on closed networks, and this kind of leads into my next point, right? When they designed these systems, they said, well, no one's going to access them, so let's just make sure that they work and that they don't blow up. And then we're good, right? And never took into account that their network would be connected to something else where people could access it. So economics still apply here. You know, I've done a series of interviews on Security Weekly with people with a lot of experience in SCADA, ICS, embedded systems, but they say in economics applies here, just as it applies to the retail scenario where I go into the store, I'm a regular average user who wants a wireless router, I buy the cheapest one. Industrial systems are the same thing. Cost is a huge factor. One of the reasons is, you know, these devices have to live for a really long time, right? And if they need to be replaced, they can't be spending that money. They're running on tight budgets, right? Think about the power company, right? Who do you go to buy stuff that says to you, look, we want you to use less, spend less with us? I mean, that's essentially what the power company is telling you, right? They want you to use less energy. Don't spend as much money with us. They would fail miserably in the corporate world. But, you know, so that applies to the economics of it, which I think is a huge issue for these industrial control systems, is they want these devices to be as cheap as possible. In your corporations, in your average everyday corporation, right, there are tons of embedded systems that are here. Building entry, environmental, lighting, cameras. We talk about SCADA, right? You probably have a SCADA system in your building if it's newer, because that's what's controlling the HVAC, the lighting, all of that stuff. Hotel key cards, headsets and phones, printers and multifunction devices. We've seen whole presentations on a lot of these different technologies up here. So why do we care? Attackers will use things as jumping off points, right? We know that. We've always heard of that. But tie that together with what I've said before, is that these devices are becoming much more powerful in terms of CPU and RAM and storage, which makes them a more viable jumping off point than before. You know, a printer 15 years ago, probably not a very good jumping off point. A multifunction device today, probably a pretty good jumping off point. And attackers will prey on these weaknesses. We've seen point of sale systems come under attack because it's a point of weakness, right? It's an embedded system, essentially. I would classify some of those as embedded systems for sure, although a lot of them run Windows XP under the covers, as we know. You know, those are certainly a weakness that attackers are going to prey upon and get into these systems, hopefully going unnoticed, because the users of a point-of-sale system, right, are processing transactions, not necessarily on there looking for malware. Physical access is not a primary concern in our corporations unless we are being specifically targeted, right? So with the SCADA example, physical access is probably pretty important, right? I care if someone can solder something onto a device and blow up something in the SCADA world. That's bad. In our corporations, probably much less likely to occur, although targeted attacks, you could see someone taking over a device in a targeted attack physically. Of course, the challenge of economics all apply. We all fight over budgets every day. Medical devices are interesting. One thing that's interesting is if you Google for insulin pump, it always comes up with this picture. Like whoever this model was is the model for someone with diabetes who has an insulin pump, which I don't think is always 100% accurate. Maybe it's just me. Okay. But all of these devices, IV pumps, I mean, how many people here work in the healthcare environment? You know of these problems, right? A couple of us in the healthcare that want to admit it. So you know of these problems. It's bad. There have been examples of a lot of research. Billy Rios and Terry McCorkle, of course, when they were at Cylance, did a lot of research into medical devices and found that there were critical, you know, settings that could allow hard-coded passwords was the vulnerability. And that's important. If we can tie vulnerabilities like hard-coded passwords to all these medical devices, and then we're going to look at some of the hard-coded stuff that I found in some firmware, that's kind of scary to me that we have similar problems across all of these industries. Okay, why do we care? Well, it's life-threatening for sure, right? Like as a patient, I don't want you getting into the IV pump to either not give me enough or too much medication or whatever the scenarios that you have. Patient care will trump security every time in a healthcare scenario, right? The ability of the caregivers to make sure that people don't die trumps how secure it is, which is kind of interesting because if we think of losing control of a device to an attacker as a potentially life-threatening situation, that does affect patient care, but not on an everyday basis. And, connectivity and ease of use, right? We don't want people to run into this situation where I can't give you your meds because the IV pump is updating firmware. That would be a bad situation. So this environment is very difficult to work in. I also think that patient confidentiality is probably second on their list, right? Like make sure people don't die and then make sure people's privacy are protected and then maybe put some security on things are typically how a healthcare organization lists out its priorities. Then it's more important to be compliant rather than secure in this environment. Okay, a lot of this is already happening. I want to call into question this article. Someone called it into question with me. They say that there was spam and phishing emails launched from all kinds of Internet of Things, including televisions and a fridge. If you read the article, there was one refrigerator. But there's no data to back this up. And some people have tried to get some data from this particular organization and have not. So I want to challenge you, because we're a curious bunch, to help me validate that if you can, or if you know anyone there. I'd love to validate that data. We've seen this year a lot of internet worms run around, Linux worms that are targeting home routers, set-top boxes, so a lot of this is already happening. Not so much on the gaming consoles, though, which is kind of interesting. There is not a lot of research about someone breaking into an Xbox or a Wii system and turning that into into a botnet or doing any kind of attack that would gain people money, doing ads. I don't see a lot of evidence. If you do, please contact me. From what I found, it's highly theoretical. I think that it's interesting because the computing power on those systems is very, very high, right? Much higher than your average home router or an embedded system you'd find in a refrigerator. But the attacks that we've seen on them are very, very low. So I think that's kind of interesting, and it could be an opportunity for attackers there. So this Wired article, what I just want to point out is that if you see malware and it's targeting a low-powered ARM chip or has a payload for a low-powered ARM chip, it's targeting embedded systems, okay? Most embedded systems are on the ARM and MIPS architecture, which for anyone that's ever done any debugging knows that you have to go buy a license to IDA Pro. There are very few free options for doing debugging on those platforms. But that's how we can see that there are malware trends now that are targeting embedded systems because of the platform architecture. Okay. So if I had to pick one example of a bad haircut and one example of an embedded system that's really horribly vulnerable that I really want to exemplify, it would be the D-Link DIR 100. Okay? And the name of the story is Inside Joel's Back Door. That's the other reason I chose that, is because I got to call it Inside Joel's Back Door. So a little background, one of my heroes, Craig Hefner, does a lot of research in embedded systems. He's the author of Binwalk, published the original advisory that I will talk about, and I will also talk about subsequent advisories from other people on this same firmware and hardware platform. As you can see, it's a complete train wreck. And there's some references there. Zach Cutlip is kind of interesting. I took some of Zach's research that he did, and I blended it with some of the other research to create a really, really bad scenario for this router. So it exemplifies a lot of problem areas. There are backdoors inside this firmware. There are default credentials. There are functions prone to overflows. There are secure, insecure web management interfaces. Okay, but this is old, kind of. Sorry, Jack. I'm just trying to make the point. This is kind of old. Craig found these vulnerabilities in October of 2013. So, but bear with me because I've got new stuff that I found like last week. So I'll show you that. It's kind of fun. So reverse engineering this firmware, which is just, I mean, if you're going to reverse engineer firmware, get a hold of this firmware because it will boost your confidence like no other. So Craig finds a special compare in the authentication process. And his compare that he found essentially says that in programming language, if your user agent is set to this string, you can gain access to the web interface without authentication. Yeah, I'll let that settle in for a moment. So that means you can access the web management interface without a password using this special string in the user agent. Now, it turns out that this user agent was special as when it was reversed, it was edit by 04882 Joel backdoor. So that's why we get to call the story Inside Joel's Backdoor. Who is Joel anyway? I never really found out. I read on like some other forum that there was a rumor that he was in Taiwan. It was someone working in Taiwan. I don't know. If anyone wants to look into that with me, I'd be happy to help because I really want to find out who Joel is and ask him why he did this, because it's bad. But our good friend Travis Goodspeed was able to point out why Joel may have done this. So essentially what that says was that there was a developer one day that had this problem. He said, well, I've got all these other processes running inside this firmware, and these other processes, they need to change settings inside the firmware. And I got this really great web interface, and I just need to let these other processes use this web interface. But the problem is to get at the web interface, they need to know the password. And the user can change the password. So what I'll do is I'll just say that if you set your username to this, you can access the web interface. That way all these other processes on the system can access the web interface. They don't need the stupid password. Who needs that? They've got a backdoor in the user agent. That way the user can change the password all they want and life is good. No. That was not a very cunning plan. Travis found this by looking at some of the other binaries that were on the system and recognizing a call to this particular user agent. Now, it turns out, now the plot thickens. Now we get to go to Russia, where on this Russian forum, we find that in January, so Craig released his research in October of 2013. The Russians found it on January 24th, 2010. But they didn't quite know what to do with it. They were reverse engineering this firmware, they found this bug, and they were trying to use it as the telnet password. Because the ISP had given them routers with this firmware, but not given them administrative access to change any settings on it. So they were reverse engineering the firmware just so they could gain access to their router. So they were trying it as the telnet password. That's the last thing you see in this forum posting, and then it stops. So I don't know if someone said, oh, this is way more than the telnet password. Don't ever talk about this again so we can take over the world, or if they gave up and just, moved on to something else, or if they found some other way into the router, because Lord knows there's about 1,000 other vulnerabilities in it. Okay, the exploit is pretty simple, right? I mean, you can emulate this with wget. I've got a DIR 100, or I couldn't get a DIR 100 actually. But that's the exploit string. Some of these other devices, so it turns out that this firmware was used in a lot of other different devices. This TM-G5240 is a T-Mobile branded router that was given out to T-Mobile customers. There's also some other ISPs which you'll see which are using this router as well. So this particular device, the G5240, you have to go to a different page to authenticate to get the status, but that string still works because the firmware is essentially the same. So this Joel, in his infinite wisdom, introduced this bug not just on the DR100, but several other models of routers that are still deployed today, because if you look on a certain website, they will tell you that in countries like China and Canada, is anyone from Canada? Yeah, excellent. So that this vulnerability exists. How do I know this vulnerability exists? It's tied to the particular web server. The web server is THTTPD from Alpha Networks. Okay, now the plot thickens even more. Who is Alpha Networks? Alpha Networks was a small company. They were acquired by D-Link. They were doing stuff for them, like creating web servers for embedded systems, likely where Joel worked to introduce this bug. Fascinating, I know. But these systems are still deployed today because this version of this web server ties back to this version. So my guess is that ISPs in China and Canada used this particular firmware on their routers because whatever reason, and then the bug was still introduced and still available on the internet. Okay, so now if you could get someone to click on a link, you could send the authentication to the router and potentially send an exploit to the router. Don't forget, this particular bug just gives us access to the web interface to change things, right? We want more. We want shell on the box to be able to upload things and control it more. You could potentially do this. I haven't furthered my research in this area. However, if you get a victim to load a web page, you get them to load up some code which is able to send a string to their router, a request to their router with the magic string set to the user agent. You could log in and potentially give yourself access or change the web configuration in some way. The problem is you have to bypass same origin policy, and that's like a whole other presentation in and of itself. So if you're interested in how that works, come find me after. Okay. But it turns out we really don't have to go there. As Craig found that there is a buffer overflow. So Craig released some exploit code very quietly. Didn't get a lot of publicity. You'll see if you search for DR100, right? Tons and tons of articles. Oh my God, the sky is falling. The dealing DR100s are vulnerable. But, you know, there's like this little tiny reference on Craig's site. It says, oh yeah, by the way, I wrote a remote exploit for that platform. I'm like, wait a minute, why is anyone talking about that? It's limited to 200 bytes of shell code. That's important for the next slide, so commit that to memory. It requires administrator privileges, which thankfully we have because of that previous vulnerability, right? Now, the benefit is we can upload and execute code on the device. Now, if you look at the web server, so I kind of fast forwarding here, I reverse engineered the firmware, I mounted the file system, I went on the file system, I found the web server binary, which is called WebS, right? I don't think the S, if it stood for secure, it'd be really, really funny joke they were playing on us. But if you look for functions in there, because it's not stripped, we can see the function and the calls. There's instances of strcpy in sprintf. Craig's buffer overflow was in sprintf, not actually in strcpy, so there could be yet another buffer overflow vulnerability in this web server. And yes, I did just take you all back to like 1999. That was fun, right? So now, Zach Cutlip wrote some awesome code that's some shell code for MIPS platforms that runs in the context of Linux. His shell code is 184 bytes. How many bytes did we have to play with from the previous slide? I'm glad you're all paying attention, thank you. So that means you can take Craig's exploit, which just has a payload in there that I think it restarts the web interface or something like that. It's Craig's payload. Zach's payload is much more evil. It's actually a dropper payload, so it's a multi-stage, so it puts a multi-stage payload in there so that you can get shell on the box. And it does that within 184 bytes, which is awesome. So you can put those two together, you can own the router, okay? So when I have more time, you can play around with that on your own. If you need help, come find me. It's a lot of fun. I didn't get the actual exploit to work. You've got to run it in emulation or have the exact device. The device I have is different, so you have to change some parameters in the exploit to make it work. I can make it crash reliably, which is kind of fun. But yeah, you can paste all that together. Anyway, it's not dead yet. There's even more because in December of 2013, right, so we started in October 2013, Russians found it January in 2010. Now, December 2013, Felix Reiter exposes several more vulnerabilities affecting DR100 routers, including cross-site scripting and a whole bunch of other stuff. Wow, staggering. Okay, now, Paul Asadoorian, for this talk, found that on the system, there is a file, I think what is it called? Oh, stunnel.pem. I'm like, hey, that's kind of interesting. I wonder what's in that file. It turns out that inside this file, I already have a drink, Trent. I'm just so you know, I don't want to forget to drink my warm Coors Light. So, not good. I was looking at this file because I had mounted the file system and there's a certificate, but there's also a private key. I'm like, what? Does anyone see what's the problem with that? Yeah, key reuse, right? This is inside the firmware. This means every device that's shipped with this firmware is also shipped with this private key, which means all the private keys for all of the T-Mobile routers are all the same. It also means that I have the private key for all of the T-Mobile routers. Kind of interesting. So that was like an additional, I see you back there. So let's, Dave, just, what is that? It's like hot. Was that in your armpit? No, I don't. It's like warm ass tea. Oh, okay, so Dave, why don't you recap the vulnerabilities on the DRA-100?
These two different authentication bypass vulnerabilities. What's CSRF?
Oh, God. That's disgusting. Thanks, Dave. Love you. So yeah, it has lots of vulnerabilities, authentication bypass, CSRF, and also the static keys that I talked about. Really, really bad. Okay. If you go to D-Link's site, and what is BR? Is that Brazil? Is that right? Brazil. D-Link's site in Brazil is running an emulation of this firmware from 2007, around the time that it was vulnerable. So this firmware version would be vulnerable, and it's running on their site. So I'm not encouraging anyone to do that. I just thought it was interesting that they were running that. Yeah. Okay, next slide. So, but now, Paul, the conditions, right? What you're saying to yourself now is the conditions that you found and all these other people found on these, home routers and all this stuff, they just can't exist on all these other platforms that we talked about, except for the resource that's up there on that slide right now. They don't. Okay. Well, that's next slide. And there are more attacks very quickly. H.G. Moore found several flaws in VxWorks. Hefner discovered DNS rebinding, which is very interesting to read about as well. There are some malware created for Nintendo Wii and DS systems, so I do have that research in there. Then, of course, the famous ATM account, ATM hacking. But anyway, so those are kind of there for your reference. So now you're asking yourself, why? Well, now you have the answer to why fucking cat tears apart toilet paper. Now you have that answer. You're welcome. But now you're asking yourself, why are embedded systems left out in the cold when it comes to security, right? So there's a couple things here. Most products or anything that you're designing for people to use is designed with two... Sure you are. Wow, makes it really hard to talk. Okay, that's at the pinnacle of this slide too. This is really good. You should pay attention to this. So every product is designed with two things in mind, right? Is the product usable? In this case, as a hammer, right? Or what did I put it? A TV, right? Okay, so whatever. So usability, right? My TV turns on. It allows me to change channels, display an image, right? It's also designed for reliability. The TV doesn't explode under normal operating conditions. That right there is not normal. That's something that happens like in Larry's backyard, not normal operating conditions. So make sure that you can use it as it's intended and that the shit doesn't blow up. What are they not designing for, right? What happens if an external user takes control of the system and does bad things with it, right? This is how we get into the SCADA devices that people are taking over, or your televisions or routers or whatever. They're not designing them is if an evil actor or bad guy were to take these over and make those devices do bad things outside of their normal specification, right? You wouldn't, you wouldn't do this with a hammer, right? Like with a hammer, I make sure that it can pound stuff. Usability, right? I make sure that when someone's using the hammer I design, that the head doesn't come flying off and crack someone else in the skull. What I don't put any design thought into when I make a hammer is making sure that I prevent someone from picking up the hammer and start bashing in people's kneecaps. I can't design for that, right? But here, with digital devices, it's kind of like a digital hammer. We have to take into account that people will use these devices to do evil things because they're connected. And this is a whole new aspect to all of the things. And it's kind of scary because as things in our own homes, in our corporations, as those things die, I'm constantly looking over my shoulder for Dave. As those things die or need to be replaced, I'm replacing them with newfangled things that have connectivity, that have these problems. So this problem is going to get exponentially worse unless we fix it. So what do we do about it? I'll let that slide sink in. So I came up with this list of things. Fortunately, being a stripper is not on the list. Fortunately for all of you. But they are the 10 most wanted list, right? And these are somewhat tactical. You could kind of roll some of these up and group them together and put higher level labels on them for management, but design engineers tend to want a lower level. So these are the 10 things that I come up with. Is 10 enough? I don't know. Is 10 too many? I don't know. I'd appreciate your help on this issue. If you have more suggestions, more than happy to talk about them. So the first thing that we have is firmware backdoors, a secret account or access created by the vendor that allows remote management, right? The problem is it's never so secret because as you can see, I can easily rip apart firmware and get into that and see the secret things that they put in. That's happened a lot. Also, if your backdoor that you're securing is secured with a MAC address that everyone can see in the network, it's not so secure, rugged comp. Okay. Default credentials are different from backdoors, right? These are the credentials that the user sees. Of course, these credentials are everywhere. The zombies ahead, of course, was the ability to hack road signs, right? You had to pick a lock and you had to know the default password. And of course, as we all know, anyone can discover that password. Now, the scary part is sometimes when you update the firmware, it restores these default passwords, so they get put back. That just begs the whole question of vulnerability and configuration management, is making sure that this stuff doesn't come back. Insecure remote management. I'll let that slide sink in too. Thought that was good. Pick a good password, right? But not so much picking a good password. Let's move on. Let's talk about how we manage these systems over HTTP, over Telnet. One of the first things I do when I get a Nessus scanner is I go into the Telnet results. This is unencrypted Telnet server, and it has a severity of low. I change that severity level to high. I want to know about that, okay? But we're still using a lot of these protocols on these embedded systems. Open source drivers. I mean, this is an issue that we dealt with in 2007 when we wrote the book on Linksys routers, that manufacturers of these chips write proprietary drivers for wireless, for Ethernet, for a whole host of things. They give us these binary blobs, and they're like, yeah, this should work with most versions of Linux. But then there's lots of problems with that. I can't, you can't, unless you work for Broadcom and are the developer of that binary blob, you can't fix problems that are in that code. You have to wait for the manufacturer to fix it. You also, if I want to do something in my platform, in my firmware, that maybe makes it more secure, but I'm held back because I got this binary blob and it's not letting me move forward because I can't change that binary blob. It's just a blob of binary code. So open source drivers definitely, I think, will contribute to better security. Functions prone to overflow. Like we all know stir copy is bad. Apparently our developers don't know that stir copy is bad. You know, it was a stir copy bug that led to some of the IPMI firmware vulnerabilities. So my suggestion is to really educate the programmers and really hit them on a level that I think that they would understand with posters that you post in your workplace. All my friends are using stir copy, but I'm not, because I understand how dangerous it is. Put some peer pressure on the developers. I respect myself. That's why I refuse to use sprintf. I think I said, forget sprintf! Exclamation point. All right, encryption. There's a couple of things about encryption and I'm sorry I don't have a funnier slide for that. I've been challenged by my coworker Space Rogue to make sure all my slides are funny, and he would make fun of me for that. But firmware encryption is important. Signing firmware updates makes it harder to put a backdoor in the existing firmware. I think that's probably the most important thing. Encrypting firmware so that we can't reverse engineer it is probably going to be met with mixed success, because we're just going to try and break the encryption. But signing firmware updates, similar to the way Microsoft signs, Microsoft Update, I think is important for things like firmware. Largely does not exist across embedded systems. Firmware updates there's no way to validate them most times. And also XOR is obviously not encryption. Linksys has tried to implement some interesting firmware encryption algorithms that aren't very good, or really what I would call encryption. User-friendly updates, right? Even when you talk to your average everyday user, are they going to want to say, well, I need to update my firmware, I need to go download that firmware? I mean, they have no idea what firmware is. We want the firmware update process, the ability to update these devices, to be very easy. Now, I think on the smartphones and tablets, that's a pretty good model to follow. It sometimes forces users to update, which can be bad. Like when my phone says I'm updating you anyway, and then bricks my phone or does something bad to my phone. I still think it's something we need to strive for. Okay, secure web frameworks. One of the reasons, I use that example of the D-Link DR100, is it really exemplifies a problem in embedded systems. These systems are so small and limited by space and CPU and RAM that you can't just take and put Python or .NET or any other web technology that's proven. Dare I say PHP? No, I won't say PHP. But a web technology framework that has some security built into it, you can't put that on a lot of these devices just because of space and CPU and RAM requirements. So what do developers do? Just like when encryption isn't available to them, they write their own. The results are pretty much the same. It's a flaming piece of crap, as we saw with the web server that was put on the other router. But the problem is with that people like to reuse it. So they'll say, well, that person already spent the time and pieced together this whole web server thing where I can change the configuration. Why am I going to rebuild it? I'll just reuse it on all these other firmwares and all these other devices. That's why we see the DIR100 problem being propagated to all of those other systems. That's a prime example of code reuse. So we really need some kind of secure web framework that works on a good majority of embedded systems. A lot of these systems are Linux-based. I believe we can come up with a nice framework for doing that. BusyBox is a standard platform for putting binaries and GNU utilities on the systems. I hope that we can come up with a standard platform for web applications as well. Okay, so maintain assert. I think that various vendors over time we've gotten kind of mixed results. Linksys actually responded, or Cisco, or now it's Belkin. Who bought Linksys? Is it Belkin? Cisco, and then I think they were talking about selling it to someone else as well. It's like the bastard stepchild. No one wants it. So I said, but in this transition, Linksys's websites to download old versions of firmware went away. And I said, can you put those back? And they were like, well, what firmware are you looking for? I'm like, well, I really need this version of firmware. Well, why do you need that? Well, I need to do security research. And then I never heard back. They're like, you can put a ticket in over here. I'm like, oh, they're so helpful. This is so great. And then I put a ticket in, and I never got they sent me like the latest firmware. You can't go back to do any kind of security research, apparently. So, anyway, it's important to work with researchers to get this done. Prezi got hacked and they paid the researcher money and wrote a nice blog post, which was nice. So there are clearly different ways to treat researchers, and we need to be able to work with that community as well. Secure protocols. On a lot of these different systems, I look at my Sonos system, I look at a lot of the consumer gear has these protocols, but a lot of protocols exist like BACnet in building control systems for corporations. They all kind of fall into the same category. Modbus for SCADA, right? There's no security in any of these protocols, none whatsoever. So I really think that we need to rethink what protocols are being implemented on these devices and build security into them and standardize on them. How am I doing on time? I have 10 minutes. Okay. Well, that maybe I have time for. Well, I'll take questions. How about that? I won't necessarily do a demo. We'll take questions. Yes. Mm-hmm. Yeah, so the question was that a lot of the vendors of and manufacturers of IoT devices, they put the onus of security on the user, and how do we change that? I think we really need to engage the user to call out security that sucks and make it a driver for spending, and then they'll stop putting the onus on the end user, which never works, and start taking some ownership of it. Yes, question. Yeah. So the question is, at what point are manufacturers responsible for the warranty and the longevity of a device and supporting that device? I mean, it's a great question. I know the answer is probably going to differ. I know what I would like to see as a consumer. I don't know what's economically feasible from the vendor, right? I like to see if I bought a version of a product and you're going to end of life that 5 years from now, I want at least some discount to the latest model. Or some credit towards the latest model, if in fact the vulnerability lives inside of the hardware. Like I can't patch that vulnerability either because it's a hardware limitation or because we're just not supporting the firmware anymore. I also like to encourage manufacturers to choose firmware and hardware that they can support for a long time. But the problem is economics come into play, and they're like, well, we just want the cheapest one so we can beat up the competition. And that's where you get these throwaway. If you look at all the different hardware platforms for just Linksys routers, there's tons. And that's why. They're always looking for the cheaper solution. So they're being cheap. Okay. Okay. That's time. I'll be around all day and night, so come find me if you have more questions. But thank you.